Hello, hello. Excuse the... Oh, wait. Alright, yeah. Excuse the, maybe the sound in the background if you can hear that. Sorry about that. Yeah, so let's see. Where were we? Been gone away. Sorry. Gone a bit for Christmas and stuff, but now I'm sort of back. The schedule, or well, I don't really have a schedule though, but usually I'll be streaming like every day, well, every weekday, I guess you could say, every work day. But yeah, now it's like off time and stuff, so it's a little bit sporadic. But let's see now where we are here. So we've got to do IR. So I think last time I wanted to yeah, continue working with the pipes, I think. Yeah, the pipes. I even aborted here. Not sure what I was going to write here, to be honest. Pipe generic source destinations executable. Yeah, I mean, this can be like blocks, function calls. Whereas blocks are basically, I mean, and also like generic values, like values that can coerce two streams of, or yeah, that can coerce the streams of bytes or whatever type that you want to have. Yeah, but these two are the most important ones. Like once we have blocks in place, then function calls could build upon the blocks. The executables, of course, very important. Now, I am contemplating, since executables do use file handles for the pipes, then maybe we could do the same for blocks, except it's like a virtual thing, or we could just use, I mean, we could just use the stream that we already have. I've been thinking about that as well, because that does have everything sort of needed right now for executables and generic sources and destinations, so why not just reuse that? Let's actually try and do that right now. So where are we actually? I've been off stream. I've been working a little bit on a TUI, like a terminal UI thing. But yeah, we'll see what happens with that. Maybe I'll just scrap that whole thing. Maybe there's already like a library that we can use just to get something up there. But it's been fun thinking about it a little bit, but yeah. But anyway, where are we going to go? So I think, I mean, yeah, we don't really have the compiler support for this. So, because yeah, I don't think we even have any binary right now support. So basically nothing binary is gonna work right now. Also, or I mean, like binary as in binary operations. So where is the thing? Compile expression. All right. What we have, the only thing we have is like assignment, but yeah, for binary expressions. But yeah, let's start here. I guess this is a binary expression. Compile binary. Hello, Fahim's Tech. How do I get into compiler development? I do web development. You just yeah, that's a good question. I was gonna say just read about it and try to do something. Yeah, I think there's like a couple of components you need. Happy New Year, Not Slider and everyone. Hello Penguin, welcome back. Frohes neues Jahr. Alright. I'm gonna guess that means Happy New Year. What language is that? Dutch or something? So basically, what a compiler, there are a couple of steps. Like usually, a compiler needs, well, first you need like the source code, right? So you need some way of reading source. I mean, and that's, you can do in a bunch of different ways as well, but let's say you want to do the traditional, you have a source file, a language. What you do is you read in that source file or source somehow through something called a lexer, which is another word of saying tokenize. Well, that's what it's doing. It's basically taking the source code and it's making these tokens that are basically, you could have like numbers, strings, symbols, like different symbols like plus, minus, you know, all the different things, but they are, now you have them in a more this step is really optional, but it's a nice way of organizing things so that you get this list. Instead of just dealing with a bunch of bytes, now you're dealing with a bunch of tokens, which are more well defined for your language, right? And then what you're doing is you're taking those tokens and then you're putting them through a parser, and the parser can be complex, but it's also like depending on what you want to do with the language. And the parser generally outputs something called an AST, which is an abstract syntax tree, which is basic. Well, it could be, you know, you could do like a flat list as well, but usually there's an abstract syntax tree, which is basically a tree structure with nodes that are basically, you could have like binary operations like add. So you would add left and right expressions. You would have, I don't know. It depends on what your language is gonna be or what it's gonna have. And then once you have this abstract syntax tree, you can then compile to, I'm gonna have these as verbs. You compile the abstract syntax tree into well, you could do some kind of intermediate representation, which you know, you could do that. You could, this is where you have the choice of going like LLVM. You can have, if you want to do a fully compiled language to like native machine code, you can have like LLVM. You can compile to some kind of assembly language like NASM or FASM or something in that sense as well, if you want, or your own like IR that you have done yourself. And then once you have, so this is like compiled to like IR basically, and then when you have that, you basically, the last step is to compile to machine code and produce like an executable. So that, but you know, if you wanna, if you're just starting out and wanna make a compiler, you could start at either end. Like you could start at this end to like think about how your language is gonna look, and then tokenize, parse, and then go all the way if you want. Or just do this part, do this later, or you can start at this point. Like you can start at writing assembly to learn. Like if you wanna, I would recommend learning a little bit of assembly if you're gonna like compile to machine code, because then you would understand more how the computer actually works. Yeah, exactly. Learning a low-level language is imperative. Yeah, I think so. I think it's very good for general knowledge about the computer, and also if you're gonna build a compiler that goes to machine code, it's nice to know what your language is actually doing, like under the hood. So I would recommend doing something like that. For the first, maybe it's something like just doing some assembly, then thinking about, okay, how can I build a language that compiles down to this assembly code? And then the last step is just to build the assembly code that you have generated. So yeah, so you could do something like that. But I'm building here is not really. I'm basically stopping here at my IR. I have this IR here for this language, so I'm not going all the way to then using the tool like compile to native machine code here. So this would be like .exe elf whatever. So I'm not doing this in my language. I'm just stopping here, and then I'm interpreting those instructions with an interpreter to execute them instead. But I'm doing all this all the way down here. I'm just not doing this last step here. All right. Compile binary. Yes. Oops. Compile binary expression. All right. So, right, and we have a bunch of different binaries operations. So I'm not gonna think about the arithmetic and all that right now. The only thing that I'm interested in is the pipe operation. Oh yeah, I just realized that pipe is actually not going in here. Actually. Yeah, the pipe operator is actually not supposed to be here. Oh, we don't have a log. Where's that log? Should probably put that in some. I have this copied. This function, I have this copied like everywhere now. Where was that? Put debugger. Should probably put that in some. Library somewhere. Hello, Nab Gaming. Welcome back. Let's see. If we have something else, we would return an error, unsupported binary operation. return that. Prefix color. Oh yeah. That's right. This is the compiler actually. Right. Path. Path. I think the path change. Right, it should change. No? Okay, well. I'm just not gonna do that. What's this? Document store. Oh yeah, we need the document store now, so that's fine. That's easy to add. Oops, document store. And we need it here as well. And there we go. Source, yeah, okay. Right, now you need document store. Whoops. Don't have it here either. No. Wait, are you on here? No. Usually have this config at the end. Compiler, allocator. Oh, I see. Power checker was you want that? That's right. All right. what's happening here? Writer error. Oh, right. This is document store error. Doc store error. There we go. All right. So what do we do? Result, yes. And this, yeah, I mean we can do this. Fall through, then you don't really do anything there. Okay. It could also just be reported, but anyway, let's not think about that for now. Unused function parameter. Yeah, because we don't have any. So I think what we'll do is we'll basically just disable this because this was not what I was supposed to implement actually. It was the pipeline. There we go. Compile pipeline. Pipeline. And you are the pipeline expression. There we go. This is what I was doing. Hello, Nav Yuva 2025. What's up? What was this supposed to be? I guess I was watching about a week. How far you came? This is supposed to be a scripting language where you, well, you basically, if you're familiar with Bash script, it's basically going to be Bash, except with a zig-like syntax, among the kind of the programming, like non-pipeline syntax is going to be zig syntax, is the idea. And yeah, it's gone up and down a little bit in this, well, a lot in this language. And right now I'm actually rebuilding the kind of evaluator part, because before we took the AST and directly tried to evaluate the AST directly. But I'm building an IR now, so we get a flat list of instructions that we can step through, which allows us to create virtual threads for the pipelines so that the pipes can be churned through as in a streaming manner, in a more like controlled way, I guess you could say. And yeah, it's going good so far, but there's a lot of things to rethink about how things are going to work in the IR now. So that is the thing. But still, it's a really fun experience here, because I've never done like an IR like this before, and yeah, it's kind of cool. So now we're thinking about the pipelines in the IR here, which is going to be kind of the proof of concept, I guess, here. Like once we've got this in place, then the rest is basically just normal programming language stuff. Oh, I see. Well, okay. Right. Yeah. So I mean, yeah, we're making a scripting language. If you're familiar, as I said, if you're familiar with the Bash, then it's like Bash, except with a different syntax, basically. So yeah, so like, you know, if I can show you here actually, so we have this MVP kind of example here. So you basically have this is runic, so this is the language here. So everything in this file here. So this would just echo hello world to the screen because we're calling the echo executable with this argument here. And the same thing here with printf and so on. So this is like, you know, this is like bash, except the syntax here down here is different with the if syntax and the for loops and everything, because it's like zig syntax here. I started, well, I've been working 10 years professionally with web development, but I've always been basically learning about programming and learning different things, and I've had this as a hobby since 30 years. So yeah, it's been a while, but I mean, I haven't done anything, any large projects or anything that has gone anywhere or something like that. But I've been like basically starting up projects and leaving them in the dust over and over again. But yeah, which is like it's good in a way because you're trying out different things, but it's also like I think it's very good to actually try to finish something, because it's like different skill set. It feels like you go more in depth in things, and you also learn how to kind of keep you motivated and how to actually finish something. I think is a good skill to have as well. I say as I'm kind of starting out a project and then switching after a year basically, but I will continue with other projects as well. But you don't have too many projects at the same time. That's also like overwhelming, I would say. Okay. What do you prefer for better coding, functional coding or traditional coding? It's interesting that you say it's like traditional, because it's like, well, okay. I won't sit here and argue about that stuff, but basically like functional is pretty old as well. Like both functional and like procedural or imperative is like almost like they almost came exact like at the same time. But anyway, almost I would say, but basically both have existed for a long time. So anyway, that is a good question, and I mean, to me it's like both a little bit of like personal preference, and also you could mix the two. You don't have to only use one. Like you could do functional coding style in an imperative language, depending on, you know, what features the language has and all that. But you can always find a way to sneak in some functional programming, like I've done with Zig. And basically the prerequisite in Zig was that you could call a function or pass functions as pointers. So you basically have a higher order function, which is a function that it's just a fancy name for a function that takes another function as a parameter. But yeah, I like both. I like functional programming a lot, and I like imperative programming as well. And the thing about functional programming is that it's nice and shiny like on the surface, but then it's some patterns are like harder to debug. I feel like because you hide a lot of the complexity, and then you have a bunch of function calls here and there, and when you're trying to debug something, you have to like jump around a lot, and sometimes it can be a bit hard to. It's easier to do like debug logging, I guess, in that case. But Haskell actually has like a nice trace function that you can use to log stuff out in any place in the program. And also the debugger is also nice because it does go into like the functions you jump around and stuff. But it's like when you have a more declarative style, then I think it becomes harder to debug, but easier to write in some cases. And then it's like when you do these abstract things, is also, that's another thing. Like the abstract patterns are not always good to have. Like yeah, but a bit less motivated when I see errors. Is there anything you can say about my scenario? Make it motivated. I mean, you're always gonna get errors. So that's like everyone have to deal with errors. So that you have to learn that. Yeah, it's not, you know, it's just after a while it becomes like, you know that it's gonna happen. So when it happens, it's not like, oh, stupid computer or something like that. Well, sometimes. It's like if you're banging your head against the wall like for hours on end, then anyone gets frustrated. But at some point you're just expecting errors to happen, and then you're like, the skill that you build up is finding out information about why the error happens, information about what is the state of the computer when it happens, and so on, and then get better. You get better and better you get better at fixing errors. So that is a crucial skill that you're gonna have to have and improve when you're a programmer. So yeah, you just have to deal with it. You're like, the thing I can say to you is that in the future of you as a programmer, you're gonna have to deal with the errors. So you can be assured that you're gonna have to deal with it and build that skill up. But it's no problem. I mean, just continue, and it's gonna, you're just gonna get better, and so on and so forth. And debugging others' code is also something that you have to live with as well. You're gonna have to live with reading others' code if you're gonna work at a company where you are not the only developer, which is, I guess, it's not really that common. You would oftentimes end up in a team, and you would have to, deal with other colleagues, deal with their code, and so on. And I say that most thing you're doing is, well, I guess it depends on where you end up, but it's gonna be communicating with your colleagues about how to solve issues, and there's a lot of different constellations there. But anyway, what would you rate the JavaScript language from 1 to 10? That is a very hard question. It's like, what would you want to gain from an answer to that question? Like, what do you want to know? I feel like there's I guess there's nothing wrong with the question per se, but I feel like there's probably not the question you want to ask. Like, JavaScript is a fine language. It's like, yeah, it gets a lot of bad rep for its strange choices in some of the like rules that it has, but I feel like it's a really nice language. It has really nice like closures. It's just the syntax is fine. It's like, yeah, I actually really like JavaScript. So it's just, yeah, just use triple equals. You're fine. You're gonna be fine. So yeah. Anyway, and also if you're gonna be a web developer, you have to deal with it as well. So, but I don't really use JavaScript per se. I use TypeScript because I can't deal with not having the backup of TypeScript when, you know, dealing with the types and the auto completions and all that. So yeah, I would recommend TypeScript over JavaScript, but yeah, that's just me. That's also like personal preference. I know some people want to go back to JavaScript because they don't want to deal with the tool chain and stuff, but yeah, I don't mind it. So hope that maybe answered your question, maybe. Happy New Year! Yes! All right. Pipelines. Feels like when dealing with this, it's like dealing with the whole thing at once. It's like, yeah, the pipeline has a bunch of stuff. We have a bunch of stages that we need to deal with, and yeah. The thing that I asked for JavaScript was I was into JavaScript for MERN stack. All right. But okay. But were you like considering using other stacks, or like other, like for backends, or because MERN is, let's see if I can figure this out. I think it's Mongo, Eclipse, or no, what am I saying? Express, React, Node? No, wait, Mongo. What's E? I don't know. Anyway, so I mean, there's nothing wrong using, you know, Node as a backend. The only thing that people like complain about is multi-threading and you know, the performance there. But because Node is like single-threaded, so the thing that I asked for in JavaScript was for I'm into MERN stack, and I was like, can I make this JavaScript as my main language so I can work on it? Okay, well, I would say so. I mean, if you're in web development, JavaScript you will always get somewhere, you know, you would always be working with JavaScript somehow if you're on the front end. Like back end wise, it's not always the case because you don't always work with Node. But there's a lot of people who do use Node. So yeah, MongoDB, Express, Node. It's kind of weird that Express and Node is like the same, because Express and Node is kind of, you know, if you're using Express, you're using Node. I mean, sure, you can use Bun or whatever, but although you wouldn't use Bun, I guess, and Express, you would just use the Bun server, I guess. I don't know. Anyway. But it's like Express and Node. Like Express is Node, so why would you have to say Express and Node? But yeah, that's my 2 cents on that. All right, so we have these stages. What do we want to do with the stages? They would want to be compiled, although now we should be like in a context of the pipeline. Or do we actually need to worry about that now? The thing, how it worked before was like, we set up a context, we executed a pipeline inside the context. If the pipeline itself was always streaming and in the background. But if you had a context that consumed the things inside. Wait, hang on. I was thinking about this, and now it comes back to me here a little bit. No. Blocks as pipeline. Yeah, I think I was discussing here how it could work. Node sucks. I mean, I wouldn't say it sucks, but you know, it works well. It's just if you want to have the most performant server of all time, Node, I think, you know, it works well, but I mean, yeah. What about Zig? I heard that Zig has its fan base. I mean, at the end of the day, I think that, you know, when you're in your position, like you're very early in your like programming, like when you're like out of school and you've worked a couple of years, the whole everything has changed. It's gonna change. So when you have like come out after a couple of years, then there might be other languages or other like frameworks or other, you know, other things in like the web world, because that's how it works. Like it changes all the time. So, you know, the skill that you have to learn is basically to keep up with the changes and just update yourself. That's like the most important skill. And so it's not as important what you choose right now, but it could be like, yeah, of course JavaScript is always probably gonna be important to know, of course. Like all the web is based on HTML, CSS, JavaScript, you know, and then some backends happen to use Node. So then if you have JavaScript, you have those covered, you know. But Zig is like, I don't think many people, like I don't think many companies are using Zig right now. They might be in the future, who knows, but right now I don't think that's the case. Zig is like more like an experimental thing right now, I guess you could say. Like in the perspective of maybe if a company is gonna try and use it. But it's a really cool language, and you know, if you want to learn like low level programming, then Zig is a good candidate. Although I would argue maybe C is better, because then it has more. Well, it's better in the sense that it has more like resources online to read about, how to learn it, and all that. Zig doesn't have that. C has a lot of resources that you can read. Yeah, no problem. Thank you. What would you say if you have give an advice to people who are new to coding? That's, yeah, like as I said, like, you know, you don't have to think about the language that you choose now is not the language you're gonna keep on doing for 40 years. You know, it's gonna change. So you're gonna learn one language now, and then after a while you're gonna try to, you know, you can try to learn other languages. You're not stuck with that language, because a lot of the knowledge that you learn in one language are gonna be you're gonna be able to translate that to other languages, because every language has things in common. And then of course there's like a distinction between function and imperative, but in reality those things have kind of merged over the years. So if you're working with, for example, C#, C# has like merged in a lot of functional ideas with select and all that stuff, and also like yeah, probably other languages as well. But yeah, so that's what I'm gonna say to you, because that's kind of the same like that you were thinking that you had to choose now, but that's not the case. Is this Vim? Yeah, this is on NeoVim, which is like a newer version of Vim, you could say, and like a fork almost. And then the Linux is on actually Windows subsystem for Linux. So it's actually my host operating system is Windows, and then I'm using Linux WSL, which is a kind of like a virtual machine running on Windows. And the distro that I'm using is Ubuntu, like a terminal-based Ubuntu thing. Okay, let's see if we can figure this out. So let's see. I had this idea last time that I kind of changed the whole game a little bit. Because the thing is here, let's just walk through this a little bit. So basically, this is not a pipeline, but it does have things in common. So this will spawn the process, and it will hello Meerkat the dev, can you tell me about your language? Yeah, it's a bash-like scripting language. It's like, you know, as you see here, it's like bash. You can call executables, add like arguments to them, and you can have pipelines. So it's you know, if you don't know bash, it's a scripting language, but if you don't know bash, it's gonna be quite difficult to explain. But basically you're spawning executables, and the output can be piped into, so you could have like yeah, pipelines like this, like echo like hello into cat. What have you implemented so far? Well, it's kind of like I have implemented a lot, but I ran into some issues with the streaming of the pipelines. And basically I have streaming pipelines as long as everything in the pipeline is an executable. But if I want to have like a function call, for example, I'm making a function and then try to pipe that into another, like put that in a pipeline, then that's a problem right now. So I'm currently rebuilding that part, or I'm rebuilding actually the whole language, almost like, well, the backend part, like the evaluation or interpreting part, into an intermediate representation, and then evaluating that intermediate representation, because before I was interpreting the whole AST at once. But with the intermediate representation, we have a flat list of instructions that we can just step through at will, and that allowed us to make virtual threads that enables us to create these asynchronous tasks, like a pipeline, for example, that is asynchronous, or any kind of function call or executable. So yeah, and right now I'm trying to think about the pipelines again, because it's kind of like this proof of concept. Like if we could get the pipelines working again in the IR, then the rest should just kind of fall in place. So yeah, that's what I'm thinking about now. Sure, you can join my Discord. It's, let's see if I can find the link here. I should put it in the description, but I haven't done that. Let's see. All right, there you go. Okay, man. So thank you, piano. Okay, let's go through this again. There was a while since I did this, so I have to like go through a bit to figure out where we are. Because I had this idea last time that I didn't write down, which was bad of me. Maybe I did write it down actually. Maybe I had it in the evaluator, maybe. I'm gonna look at to-dos here and search for IR, debugger. No. Where did that go? No. Not sure. Okay, anyway. So, this, of course, it spawns echo hello. And if we look at how that works right now, we are looking at the evaluator in the IR. Right, because we have the call instruction, which has this argv. Yeah. So we have this call thing, yes. And so we actually we'll build this stuff here. We spawn the child. That's right. And then we kind of bind it to a virtual thread. So we open up a virtual thread and we set the process of the thread to be the child. So basically every virtual thread has one process it can be associated with. And then so we associate that with this child so that we can and then we have to wait for that later. So basically, but now we're actually waiting for it immediately here. So this, the calling thread here actually waits for the child immediately in the call. But that's not what we want to do. All right, thank you, Navyuva. See you later. Happy New Year. So, but this is not supposed to happen. This is just to make it work here. In the IR, actually, we have this IR thing here, yeah. And oh yeah, so we did have this as well. Yeah, this all works. So that's what we have there. But this is not how it's gonna be, of course, because we might want to spawn it in a pipeline, for example. Then we don't want to wait for the child. Like, it could work for, like, it works for non-streaming, but everything has to be streaming, right? It's like everything is streaming until we bind. Then we evaluate, like everything on this side, we evaluate to put in S. Now there could be an argument that we could have full lazy evaluation, that we could continue without this being evaluated fully. But then there's an issue, because there might be side effects of the, like the commands and stuff, that we don't actually know about in the language itself. So anything here could spawn like side effects. I guess unless it's now of course this is a constant literal, so this doesn't have any side effects, and this doesn't have any side effects either. But if there could be something like move something, that would have some kind of side effect that we need to do at this point to be able to reason when things are happening. So this actually has to evaluate the whole thing, and then we move on to here, which also evaluates in before we reach the next line of code here. So this should evaluate the whole thing, and then we move on, of course. But yeah, so here we would not do this. But then the question is like, when do we wait? So that's now the context. The context of this expression, like when do we actually decide to wait for this? So it's going to be either when you bind something and when we do this again. Just explain this, but yeah. But how do we then wire this up correctly in the IR? Is the question now. Yeah, that is the question. Like either we can build up primitives in the IR to enable us to actually do this in IR, or we go the other way by implementing like special instructions that allows us to build a context, perhaps. So when we execute the statement, we push a context and we pop it and so on. Or in the IR, we would implement something like, I don't know, that we get like the process ID from this call, and then we wait, and we have a wait instruction with wait, which just waits for it. So that could be something we could do. But then it's like the question, okay, but where is the result stored? And where, like, because it should stream to some destination. And in this context, the destination is like the outer context, which is just standard out. But if you have something like a binding, like, this, then the context would be in memory to be stored in this variable. So that's what we have to figure out how to do in that case. Like if we want to do it like in IR, like, okay, we could call wait, but then we also need to, like, instead of storing it in standard out, we would create maybe like a new writer to be stored here in some way. Maybe in the IR we could have that. We could have a value type that you could write to, perhaps. All right, Meerkat. Happy New Year. Thank you. Yeah. That could be something, because then that could be like the in memory, and then we bind it to this variable here. So we could bind this variable to a writer, a stream thing, and connect this to this. And then at the end of the statement, we simply have to kind of wait, because it's a binding, so we have to wait for. Okay. Oh yeah, that's what I think. This is what I was thinking. Yeah. So anything to the right of a binding would be its own thread that we have to wait for. Yeah. That's what I was thinking. Well, that's one of the things. Like, I'm trying to remember, because I think I came up with a pretty nice solution, but I'm trying to remember what it was. But yeah, that was one of the things. Like the things to the right of the binding is in its own thread, and we just wait for that. So that should be good. And then this is like called, so it technically would be its own thread as well. And so we just call this wait, but we don't wait for this, but this thread would actually be its own kind of statement, which should wait for its all the statements. I mean, I guess it could depend on what the contents is. Like if it's a block, we spawn it in a thread and we wait for. Oh yeah, wait. Now it's coming back to me. Now it's coming back. Okay. Yeah. So I think, yeah, because before I was thinking like, okay, how should this work right here? This is a pipeline, right? So we have this block here with 2 echoes, and then we pipe this to the cat. So it's easy to think intuitive what's gonna happen here, because this thing is piped into cat. So this thing is echoed, hello, gets put into cat first, and so on. Then this is gonna get put in there, and so on. So that's easy to conceptually, like to intuitively think about what's gonna happen here. But when I was thinking like the solutions here, so the first solution I was thinking about was like, okay, well, let's say that we could run this block in a kind of like a generator manner. And so that means that you would run part of it, which yields some sort of result, which in this case yields a, you know, a process or a pipeline. And then we connect this to this pipeline down here. And once this source has been depleted, we can continue execution. We reach the next one. That would then be connected here, and so on. But that was one solution, but it's unnecessarily complex, because what we could do is like this whole block, if this whole block could have its own pipe, output pipe, then these two would not connect directly to cat here, to this pipe. They would connect to the output pipe of this block, which then is connected to pipe. Because then we could just churn through these statements here like normal, like we would in the outer context. Like we would just execute this, wait for it, it would output, it would connect this to the context, which is this block out, like the context here. And then when it's done, we just continue here. So as normal, like that's a normal execution. We don't need to have a special kind of execution thing for that. We just need to connect the pipes, create the pipes, connect them properly, and we don't have to have a special execution thing here. So that was gonna happen. So when you encounter a block, we spawn a thread, we create a pipe for it, like output pipe, input pipe. We will, everything that's echoed from in here is gonna be put into the output pipe, and then we connect the output pipe. If there's a pipeline here, we connect the output pipe to the pipeline. If there's no pipeline connected, we connect it to the outer context instead. So this was your this would just output to the standard out, and this would output to cat, which of course just puts it to standard out as well. But yeah, so that is the solution I think that I came up with. Yeah. All right. Yes. So we need a mechanism to be able to create these pipes and connect them, disconnect them. We also need a mechanism to keep track of the context. We need a stack of the contexts as well. So yeah, and then we need to be able to get those pipes. All right, cool. So I'm gonna go to instruction, and actually, you know what I'm gonna do? This source thing is not important. I'm gonna move you down here. And here's the type. Actually, yeah, okay, whatever. So we do have these things, which it was kind of meant to be something like that, like having some sort of context stack. As before, when you had like identifiers, we have what else do we have? We have the pipes as well, like standard out, standard in. Those, like the file handles, basically a file handle, kind of like a fine handle binding stack. It's a file handle scope, basically. Just as you have scope for variables and identifiers for those, you would have scope for the file handles as well. Well, these special kind of file handles, yeah, because they could be redirected and all that. It could be like a redirection stack. I mean, that's basically what it is. I'm just thinking about a little bit on what the structure of this would be. Because let's say you're in some sort of scope down here, you want to figure out, okay, where's my standard out going? It's going to some kind. It's going to whatever context is over here. Standard out. Where is this going? It's going to some context over here. This is going to the outermost context, so this will be the actual, you know. Let's say, well, 1 for standard out. Let's say this is the thing, and this would be like, you know, the kind of the outer standard out here, and this would be outer. So we have this scope structure, right? And so if I want to echo something to standard out, then this would refer to this. This would refer to this. So it's like a scope stack like this, you know. I'm just thinking if there's other ways of doing this. Because really these are just aliases at this point to this. So they could just be pointing to the same thing. And in the sense of these scopes, this could basically be... This doesn't really change. You can't change where this is pointing to from within. So we could just copy this directly. Like this could be copied here. Yeah. But then, yeah, okay. But then, like, yeah, technically we don't need to create like a new pipe here. Well, I guess we do, maybe. Well, it kind of depends. It depends if it's just a naked block. If it's a binding, we do need to create a pipe. But, yeah. Yeah, so this, like, when you reference standard out, you're referencing the inner standard out, not the outer one. That's the thing that we need to have. So it's basically just like a scope, and then whenever this block exits, we have to pop this off, and this exits, so we pop that off. And now when we reference standard out, of course it's going to be standard out. It's going to be this standard out here, and so on. So that's the basic idea there. Yeah. I'm just thinking like we could, the pipes, I'm just thinking like how would the pipes work? Like what are their could we use, I was thinking like could we use the built-in files for this? And maybe we can actually, because they are like, they should have everything we need to have for dealing with a data flow. Atomic file, what the hell is this? I'm not sure what this is. Something to do with multiple things accessing the file, probably. That's usually the way with atomic stuff. But yeah, we have the file, and of course we have a handle which is always specific. We have a kind, so I mean we could have some kind of name pipe, for example. I'm not sure if this is available in all operating systems. But you know, maybe we could use something like that. We could create like these pipes. I'm just thinking what we need. So the way it works now, like if we go to the stream construction we have here. So basically we have this type here. This is the pipe struct that we have right now. So this is like a reader-writer stream. You can write to it, you can read from it, you can connect source and destination. So you would have this between echo and, you know, standard out. So this, the part of this is this part here, the pipe part, which reads from this process and writes to standard out, right? That's what this is doing. But you have to call this forward function to do it. So this forward function needs to be called. The job of the forward function is just to read from the source and then write to the destination, which we're doing with this stream thing here, which is a built-in function in Zig, in standard library, which is a really nice function. Okay, so that is yeah. Where is the thing? Okay. And also what's nice about this is this agnostic of what source is. Like it needs to have the it needs to be a closable reader. Destination needs to be closable writer. So that means that we can close it when we're done reading, which means that when you have this echo hello and we close it, we actually also exit this process as well. So this process is terminated. It's done. We have the bytes that it's has forwarded to standard out now. We don't close the destination though. But we do close the source. I think we don't close the destination actually, but probably don't. I'm just gonna refresh my memory here a little bit. Okay, we do close it if we have it. Okay. Right. Yeah, that's right. Okay, so the way we solve it is basically we don't want to close. We don't want to close standard out of our main process. So what we do is we wrap it in a closable that basically does nothing when it's closed. That's right. So anyway, so we have this. Now let's say you have some other stuff in here. So we have some kind of my function that kind of processes this thing, and then we have my function that puts things out to standard out. So now we have two pipes, two of these. The first one has the source of echo, of course, that's a process, which has a specific like implementation of this interface. So this is like an interface here. And we have a specific implementation of the interface when we're dealing with processes. And then we can also have a specific implementation when dealing with functions as well. So that's why we have this like generic, this is like a generic interface for anything that can be, so this is anything that can be closed and read from, and this is anything that can be closed and read to, or I mean written to. So these things have like just the standard like IO reader interface, and then my own like closable interface, which is you can call close on, and you can also get potential like result as well. And then the writer is the same, except it has like a writer and then a closable there. Okay, and then this pipe itself is a closable as well, so you can close the pipe, and it's also a writer, so you can write to it directly. But I didn't implement the reader interface because that wasn't needed. And yeah, so we can use this to forward data from one process to another, or from one function to another process, or from process to a function, or from anything that you can read from and write to. So yeah. Now, how do we close this bag here? So we have these scopes, and these are the scopes we have. We could just add this type, I mean, in the other scope thing, because we already had a scope for and this scope is like the old scope now, which had all these different kinds of scope types, which we're probably gonna need as well. But the single is basically like the bindings, but we don't have for pipes. Wait, where is that actually? No, it's the forward context. Yeah. The forward context is the pipe. So this has all the pipe stuff. So it's describing where the pipes should go in this context. Now, thinking that we probably want to have a more, like, if we're gonna be able to copy bash, because I think bash can technically take any file handle to redirect to something else, maybe. In a certain context. So I think what we need is something like the bindings, but instead of being variable names or identifiers, it would be file handles that we bind to destination pipes, and standard in. Man, I forgot about how that worked. Because standard out, standard is like, yeah, we're redirecting standard out to something. That's easy to think. What about standard in? Now I have to, my brain has to go through all this mental gymnastics again. Redirecting standard in sounds weird. Basically, yeah, we're forwarding standard in means that it's something we read from. Yeah. It's just that it's like when you're referencing standard in, we have to determine where do we read from. And standard out is like where do we write to. That's right. So we're not really redirect. Okay, I'm not gonna think about that anymore. It's basically, it's like, okay, where do we read from? This is where do we read to, or I mean write to. This is like where do we write to for this one. So it's kind of like, well, this forward context is, it does have a specific behavior for standard in versus standard out, standard out. These are outputs, this is an input. So that's also you have to think about. Maybe pipes always are like read write. Yeah, they should be. Like if you have a file that's could act as a pipe, for example, because you can redirect something to a file, and you can read from a file, you can write to a file. Yeah. So we shouldn't make a distinction there. So we have a list. We have this this kind of map of bindings from a file handle to a destination pipe, I guess. It's just that in the case of standard in, it's always going to be read, and standard out is always going to be write. But if it's a file, it could be both. Okay. So it's kind of like bindings, except it's for file handles. I'm just trying to figure out what it would be called. Like here it's called forwarding context. I guess we could call it the same here, forwarding. All right. And yeah, we don't really use this yet, the push thing. So, and then we have pop, which is kind of it's agnostic about what we actually pop here, but yeah. All right. So push. Actually, you know what? Let's go to the compiler and let's check out what we are doing in the binding thing. Wait, we have scope here as well. Oh yeah, this is the actual scope. This is like the actual scope thing. But that should be part of the evaluator, I would think. Hang on. No, that's right. If you, let's say, the binding is a result, which is now it's just a value. Could be a location or it could be a literal value. So when we declare, we put the thing there and we do a lookup. Yeah, we will try to get the binding there. Yeah. We're looking for the binding in the innermost scope first, and then we're moving out until we find something, or we don't, which means we didn't find it. I'm just thinking how this works in the context of the compiler. Because right now the instructions for a binding, it doesn't actually do anything. Actually. Like if we look at this code here, this instruction here doesn't actually do, it doesn't compile to anything. Oops. The hell? Okay, that was a weird error there. So this, and also as you can see here, the binding like this doesn't actually block the output here, but the binding, like if we go to the instructions here, you can see that the first instruction actually refers to line 2, which is this, which has the X. So that's the first instruction. It refers to line 2. So this doesn't actually have any instructions, which makes sense though, because it's a constant and it's bound to a literal. So that shouldn't have instructions. So that's good, because then, you know, you can refer to S anywhere here, which will, so that is good. Yeah, I think that's fine. It's not like we're not declaring variables in the IOR. Yeah, okay. But we are kind of doing it when we're working with redirections, I think, maybe. Hello, Blue. Welcome back. How's it going? So how would that work though? It's like we spawn a process that gets connected to something, like the output has to be connected somewhere, and the input also. Well, maybe not the input. The input is optional. The output has to be connected somewhere. Now, I guess input is always connected as well. Maybe not actually. No, wait, if a program requires input, like let's say you call a function or call a, whoops, let's say you call a, you know, get, I don't know, get line, so you get some input, like this has to be connected to standard in. Yeah. How does that work though? Like how would Bash know? Because if echo gets connected to standard in, and then like waits for that. What if you just call cat by itself? I think it just blocks. Yeah, it blocks and just echoes out. Okay. So they are always connected to standard in. Yeah, so both standard in, standard out is connected to the current context. The question is more like this, like could we semantically know what the context would be? Do we have to keep track of that in IOR? Like would this be equivalent? Like first we have these special bindings like standard out, you know, something like this, of course, some, you know, standards to. So let's say we have these, like this would be some kind of instruction, maybe, you know, so this would be that instruction there, and then we would when we have this one, we basically, we will, when we call this, whenever something's called, we actually always connect to standard in, standard, standard, and then let's say we have, but let's say we have a pipeline, then we would, in this, so this would be then compiled to, like, well, first we have the argument hello, so this would be pushed to the stack. We call echo, actually we push echo, this is the kind of how it works, like we push, well, not exactly, but we kind of, we push all this, like number of arguments, the things in reverse basically, and then when we call, we pop that, this consumes all this. Well, basically what we're doing is actually more like push, and then we have a struct here which is like executable, or actually it's like argv is echo hello, and wait, what do we have more? I don't know if we have anything more actually. I think that's all we have actually. And then we call, which will pop this, and then call that. All right, Penguin. By the way, did you answer before? Like, what language was that? Was that Dutch or something? And then, so we call. This will pop this automatically and call this. And I guess it would also like automatically connect to these things, but we don't really want to do that actually. Before we do that, we also want to, because we have this pipe here, we also want to create a pipe that pipes into cat in the end. So we actually want to create a pipe here somehow. So we have, let's say we have a ref here. So we have a ref. So I don't remember what it was called, but we have an instruction like new ref. Let's go to the compiler actually. So new ref. We have the we have this ref thing, which is a ref. So the ref actually has an address. Oh yeah, that's right. The ref has an address, and the address is actually maintained, like the address is known. So let's say this is the first ref, so it would have the ref 0. I think. Yeah, this is like relative, this is like local to refs, so it would be 0, I think. Yeah. And then we would actually set that ref, so this would be like 0 equals kind of like, we need like a new pipe, so this would be like some kind of pipe, you know, pipe value. So we would have like IR value, we would have some kind of value that corresponds to a pipe. Maybe it's the stream, I'm not sure. Maybe it's something, it's probably something else. It could be a struct that is like a special type that is a pipe type, something like that, I'm not sure. And then this pipe would be like the reader would be, so if you want to read from it, from cat, well, I guess for now it would be null. And then the writer, actually that's like a buffered writer for now. I think what we need here is the reader writer streams. Actually, this would be a reader writer stream. Yeah. So the way it works is that whenever this is created, it's not connected to anything. So it would have a buffered writer. When you write to it, it buffers in memory. And you wouldn't read from it directly, but you could write to it. So it could just be created by itself, and then you could connect it later. Whenever you're connecting it and it has data that has been buffered, it actually dumps all the data to the destination directly, and then you can continue to stream after that. So we don't lose any data there. So it's gonna buffer that. So we're setting this, we're pushing this, we're calling this. This would actually, well, actually now we need to now set standard out to be redirected to the reader writer stream. So actually this would be redirected to this ref here. So standard out would be redirected there. Standard in we don't redirect, or yeah, that's gonna be the standard in. Okay, and then the cat is going to be something else. So now we're pushing argv cat. Oops, and we call. However, now we have to set standard in to this. And after this is done, actually, yeah, and then we also need to set standard out to back to 0, back to this. So that could technically be a ref that we do. But okay. And then we call this. This would connect to these things now. And then we say, after it's done, we have to go back now because we're out of this scope of this thing. So we have to go back to this. But here's the thing. How would we kind of keep track of this here? Like going back to this. Actually, this will be 1 here. And this is 1 as well. Because I mean, we could keep track of the scope, I guess, in... Yeah, I mean, I guess, yeah, we could keep track of the scope in the compiler, just as we're doing with the bindings. Okay. So what do we need to this? For this, we need kind of like a new address type or location. Yeah, new address type, which is going to be these things. These are special as well, like standard in, standard out, standard. They are special, but then there might be other file handles. I was thinking like, okay, well, we could map these to addresses, but the problem is if we want to have like file handles, the address of a file handle, what would that be? Because it could be like any arbitrary number and we wouldn't want to be able to have to map that number to some kind of file handle thing. So how would that work? Unless we make them into refs. So this would be like ref 0, ref 1, ref 2. Set standard in is gonna be, well, no, yeah, so this would be like implicitly standard in, standard out, standard out. And if you want to make a new file pipe, you would have to ref it and then pass around the ref. Yeah. So at standard in would actually be referencing ref 0 or standard in. Yeah, standard in with ref 0, standard out with ref 1, standard out with ref 2. Okay, yeah, we could use refs actually. And then we would set, ref. So 0 would be set to standard in. 1 would be set to standard out. 2 would be set to standard err. And then this would, of course, be, 0 in Linux. And on Windows it would be something else. But on Linux is this. Because then we could potentially have other things, like you could add a new, let's say we want to have a redirection to a file, we create a ref, we set that to, some kind of reader writer stream that then we would have, do we have to have some kind of connect thing? We have to kind of connect. Yeah, we have to have an instruction to connect the pipe. Actually. Like set output of this to the input of this, right? So this would read from this file and put it into the output, and then we could have set input of standard in to the file. So this would, like, anything comes in from standard in would be outputted to the writer of this stream, and then we would read from the stream would be outputted to standard out. We could also call it like forward, keep the forward output, forward input. Is there a difference here? Yeah. Or is it actually, is there a difference here? This is automatically the reader, this is the writer. Source destination, right? We don't need to specify output and input. So this would be the same thing. We just forward or redirect, I guess, is another word, but I'm using forward here. So we're forwarding from this to out, and then from the standard in to this. So this would just connect, standard in to standard out, basically. Okay. Yeah, because that would make that would enable us to, like, in the IR actually do these things. So this would be kind of the initializer script, or the initialize instructions that initializes the outermost context here. And then you can create any kind of pipes willy-nilly. So this would just do that. We're gonna have to figure out how to deal with files later, but I mean, yeah. And then once we have this, we could also say wait for this, because then we can say that, okay, well, if we're trying to wait for a pipe, what that means is like we're waiting for the source of the pipe to end its thing, and once it's done, then we're done. We've waited for this pipe. Okay, I think with this we're probably pretty good to go. Question mark. So we need like the we need the forward thing. We need to be able to set to a file handle value. Okay, so let's actually do that. Yeah, we need like a file handle value actually. File handle. Hang on, file handle? No, wait. We need a reader writer stream. That's what we need. Yeah. So actually, it's a pipe. Yeah. Deserialize. When would we need to? I forgot about this. When do we need to deserialize that? When we call, we deserialize the well, that's a stream, right? So that doesn't matter here. Yeah, I'm not sure. I'm not gonna think about it right now. Now here is like, can we even serialize in that case? Like, do we want to do that? I'm not sure. Yeah, it's like when we're trying to deal with the arguments to a function, we're serializing. Yeah. So I think we don't need to worry about this for now. All right, we have a bunch of things we need to do here, but we also need the instruction. We need the. So I don't think we need these instructions here actually. I'm just gonna remove those. Pop like the push. Yeah, let's just remove this. All right. Now what we do need is the forward. Forward. So this would have two things. Forward. A pipe to another pipe. So we would have source. Now these are locations actually, so this would be like an address. Well, yeah, this could just be location actually. Location, destination, location, I think anyway. Yeah. And then we also need the wait instruction as well. Wait for a pipe or process to exit, to be closed, and this would have I don't know, is it the waitee? What would that be called? Anyway. Okay. So we have a bunch of new things there. All right. I guess this would have a format function as well. So this would be like forward. Of course, we need this classic 3-letter thing. 3 or 4. I'm gonna allow up to 4. Usually 3, unless you can, unless it's a 4-letter word, we use 4. All right, forward. So this is like the generic thing source. Wait, what is this instruction? Forward. Source. Oh, I see. So we have to implement this here. So no. So this would be oh yeah, the type itself has a format. There we go. So this has a format. Okay. Ref. Yeah. So forward and wait. Very important to get these in place. Okay, but this would refer only to the arguments. So this would be the source and destination. So we would just do this. And source, destination, there we go. And we'll just copy that. And this would be just one, which is the waitee. There we go. All right. And what is this? Compile call. I mean, I guess. Well, this forward. I mean, this. Wait, no, that's an oh yeah, the pipe. That's right. The compile call. So if we have a pipe. Wait, do we even have that as a value that we can use here? I'm just gonna add it here. All right. And materialize string if we have a pipe. Not sure what we are going to do right now. I'm just gonna do this for now. Okay. Of course, we have the pipeline thing. So yeah, this is where we need to actually implement this here. All right. And of course, you need to return something. So I'll just return that for now. All right, so we got this up and running for now. Okay. I'm just gonna do this here so we can see what's going on, or so we get a don't get a bunch of errors. So I think that, as I said before, like this should be like the initializers thing. So let's do that in the compiler, I believe. Compile here. So then we actually here we actually want to set up those things. I tried to code out. Hey. I'm guessing you're the guy that codes with different names. Happy New Year. You didn't stream for a few days. Yeah, I've been busy with family and stuff, so yeah, that's what happened there. And it's probably gonna continue that way for a few more days. We'll see when I can get on. But basically on, I think it's like on Monday, or no, wait, not on Monday. Wait, when is it? No, on Wednesday, I think. On Wednesday, yeah. So in about a week, I'm gonna continue on normal, hopefully, because there's a little bit of turbulence going on at where I work right now, so I might be having to spend more time there, but we'll see. Hopefully not. This year is gonna lock in, so I change my name first. Oh yeah, cool. Just keep on going, man. All right. So yeah, so let's make these refs, I guess. The thing is, they are gonna be kind of like global refs. So I guess we need them to be somewhere. So we would have like standard in ref would be a ref. Actually, let's do, I think it's gonna be like an address. Standard out ref, standard ref. So these are all addresses, and we set them all to undefined first, and then when we compile, we set them here. So we set standard in to a new ref. So new ref source doesn't exist. Name is standard in, I guess, to differentiate between other things. So standard out and standard in, no, right. So these are like the basic types that we create here. All right, and that we need to also set them. So we're gonna set the location is, wait, are we really working with locations here? Okay, maybe we do want these to be refs. Oh, we get locations. Okay, so let's actually make these locations. And of course, try. How's the new year? It was good. Saw a lot of fireworks and ate some good food and stuff. Sorry, it's 2nd of January here. Yeah, here, same here. Will you release the thing you build, or are you using it for yourself? Like right now, I'm mostly using it for like personal entertainment, building the thing. It's like the build process in itself is fun. But yeah, I am building it for myself, and I mean it is freely. It's gonna be freely available for anyone to use if they want, but. It's like that's not like my highest priority to make it like usable by other people, but I will probably try to do that a little bit more. But I'm right now I'm just trying to make it work first. Location is standard in ref, so this would now be a value, which is going to be a pipe, which is going to be try reader writer stream. No, actually it's stream. Yeah. So it's stream dot. Wait. Oh, right. Reader writer, and then this is allocator. Label is that. All right, so now we have this pipe here. Cool. I'm actually gonna move this, so this would be like compile initial. Don't have any results. It's gonna be a special thing here. Okay, so that's the standard in pipe. And actually, no, we don't set it up now. Like we set it up during we set it up during we set it up during so actually what's happening here is that this is set to a reader writer stream. Actually, that's what's happening here. And then we're saying connect or forward oh wait, now we need the actual standard in. I guess this is super special, so we don't really need to do anything there in the IR. Like this is like super special. These things are super special. Yeah. Welcome back, Penguin. Did you answer my question? No, you're never answering my questions, Penguin. Okay. Can you share the portfolio link? It's in the description, or I mean, yeah, the GitHub repo link for Runic is in the description. And the IR stuff is in another branch right now. 0, 1, 2. Yeah, so we won't be able to refer to the actual standard in standard out in the IR. They would be like referred to from these things. Yeah. So when we compile, like when we do this, do we connect them now directly? I guess we could. Standard out, standarder. So standard in. Wait, what's the issue now? Oh. Okay, there we go, that's it. And then here we need to say standard in source, connect source to the closable reader standard in, the actual standard in. So but that's the problem right now, because we don't have a way to do that right now. I guess we could, in the compiler or in the evaluator, we could just we could do it there, I guess. Yeah, we can connect them there. We can always grab those 3 items out and connect them. We could, I mean, technically we could make special connections. We don't technically need these pipes in between. Or maybe, no, we do, because we need to make this uniform a uniform value type. Yeah. But yeah. So we go to the evaluator. The actual website people make. Huh? Which website? Like, I don't really have a portfolio website. I have my website, which is this here. Hello, Subedara Unknown. Thank you. Good luck yourself. All right, thanks. Thanks, man. Are you a developer as well? Okay, so let's see, evaluate, or what is it called actually? No, yeah, we just step through. So, but we have this init. Yeah, so we kind of need. So we have init. So what we need, we need. And then we have context. Maybe we could put it in the context actually. Oh shit, I forgot about the context. I forgot about the context, the whole context thing. Okay. Yeah, because each thread has its own context. Oh man, now it's even more coming back to me. Okay, yeah. And then we have the shared and private, yeah. And the private does have, well, we don't really have, actually it has its own refs. Well, there you go. Did I just do all this in vain? Maybe not, because you know, you always want to be able to forward things. And now we actually have a way to set these things. It's just that, like, okay, so let's say we call this we don't need to reset these if we call it in a special context. Also, this would be like ref4 here. Set. No, this is forward 0. Actually, forward 0. No, standard in. Wait. Read from this output to standard out. Okay, yeah. I think actually here we could put this in a separate space, like a function space. Call the function in yeah, I usually did game dev. I mean, technically I could do like any kind of dev, but I mean, like I could stream. You know, you never know what I'm gonna stream. Is what I mean. But yeah, I did game dev for like a year, and well, I have a little bit of pause now because I'm making this language, but I am gonna continue with it. Right now, building the AI wardrobe where a user can put the image of them and dress pick before trying an AI to generate the image with that dress. If all good, they can buy from site. Oh, cool. So you have a dress that you sell, and you have a picture on it, and they would be able to kind of see how it fits or how it looks on them before they buy it. That's kind of cool. Hello, Polaris. Thank you. Have a nice day yourself. Okay. Because if we have this in a in its own thing, we could actually have like its own. Yeah, it has its own refs. So this would be, we remake all these refs. One. Why do I get this error here? And we set them here. And we don't need to forward anything yet. Let's see. Yeah, we set these things now. But then the problem here is that these now actually needs to be referencing things from the outer scope. Actually, yeah. But that's what we could probably fix if we implement function. So function, we need functions, function spaces in the instructions, and then we also need to be able to pass arguments. Somehow. using the IR. Oops. Yes, exactly. Ah, cool. What kind of stack are you using there? Okay, so I'm not sure what we should do with like the return thing. It needs to like exit the function somehow though. I think what we could do is we could have this function space. We could actually have, you know, a fork thing. Spawns a new thread at the given instruction address. Instruction. And we probably also need arguments. Or we push arguments before, depending on the function signature, the function would pop those as well. Yeah, we could probably do that. So we fork, that would be sort of the same thing as this. So let's copy that. Fork. We don't have a condition. We don't have this. We have a destination, I guess. Okay. And do you have a format? Yeah, I think so, yeah. So we simply do that there. There we go. And then we add this over here. Fork. There we go. Cool. Expect the expression. Yeah, so I guess, yeah, if we're null. Actually, what is the type? Actually, it's type of null. If it's type of null, can we just chorus it here? I guess. Okay. Okay, we need a bunch of stuff. Okay, now let's see. We have fork. So this would now actually, so let's say this I think we need like function addresses that are not fully realized yet as locations. Because yeah, the function and data does not share address space. If we look at instruction address, we kind of have this thing going on. I guess we could have a oh man, man, but then, okay, we need kind of like a separate... Hang on. So when we compile, let's say we compile this, how do we put things in the instruction? Like, how do we put things in the function and we don't know where it would end up? Because all these functions, they basically assume that we're at the current instruction, right? We have one list of instructions. Now we suddenly have multiple islands of instructions. So I guess we could add, like, to all this we could add some kind of context maybe. Because we have this add instruction, right? That just adds to this just adds to our list of instructions. But we probably don't want to do that. Now, we want to have like a map to instruction sets, where the map is like a map from function names to the instruction set. And then we like link them together at the end and realize all the kind of addresses. So this would be like instruction sets string, well, I mean, yeah, this could just be an array list actually. Of instruction sets, and yeah, then we could still use, well, no. Yeah, we need now a new address type of the instructions. If they refer to something outside of its own function, they actually need to store the address in a new way. So we would need like instruction address. So we actually need I guess I'm gonna call this remote. No, what the hell, let's just call it remote. But that's no. Okay, it kind of implies we're dealing with some remote machine or something. This would be set instruction set, another instruction set, which is going to be. So basically this is going to be a recursive thing. No, that doesn't work. It's kind of like we need another union layer here. We need one that is either a local, which is these ones, or these. I guess these ones would be local. This could technically be yeah, the labels are probably, yeah, the labels are global, but these are local here. So I think we'll do local and remote, or local That sounds even more like that. I'm just gonna have this. Okay, and then we have the local is a union enum this. And then we have the remote, which is a struct, which has the instruction set index, and then also the local address to that. There we go. Yeah, because if you have a label, it's just a label key, so we can just use that directly. We don't need to worry about that. But then we have this. Yeah, I'm not even sure we need this. We could just use labels, to be honest. Perhaps to refer to other places, actually, because they are global. So, but they are not. I guess they're not fully realized. No, but this would refer to the local address of a remote. Yeah, so it would be realized, except. Yeah. Okay. Yeah. And here we need to do like. Well, I'm gonna copy that, put it over here, remove you, and format, and this would basically be something like I'm gonna do double. This is going to be instruction set and local F. Actually, let's do single like this. Let's do double. These have these in here, so. Maybe they shouldn't, actually. Maybe we should do this. And then over here we would say local and remote. Actually, yeah, let's do that. You're local, so that would be this. Yeah. All right. Cool. So now what? Now we have that. So now instruction addresses can refer to any of those, anything in the islands, different islands of instructions. So we'll remove the instructions. I mean, we might have the instruction, like at the end we would have a full instruction set. We need to kind of link them together. But I'm probably gonna remove it for now. All right, now the thing here is like, yeah, we added the instruction. Now all of these actually need the set identifier now. So we need some kind of set to do that. So this will be instruction sets, and then items set, and then we add to the set. And also what we need is another function that is like add instruction set, which would give us the set ID back, and this would append here, and this would be like init there, and then we return instruction sets items length -1, That's the index. Oh. Alright, let's just call this instruction set. There we go. I'm gonna remove that for now. Alright. Current address. So it depends on the set. So instruction set. This would be instruction set. Instruction sets. Top items. And get address. Yeah, I might have to go here soon. A little bit in the middle of something here, but yeah. Oh, set label address. Okay. Unknown or absolute, right. So we also actually need the set instruction actually. I guess we don't really need it for... Oof. Yeah, the address. This is only for instructions, I think. Label address. Yeah. I'm just gonna be once again. I'll probably have to leave here now, but anyway, that's gonna be it for this time. So thank you very much for joining me here, and I'll see you later. Should I read the script in order to find the right product? Do you have any other solution? Wait. Oh, I thought it was the other guy who said it. Okay. What do you mean? Scrape the internet to find the right product? The right product for what? Alright, anyway, I have to go now, so